So this is our third nervous system video. It is all about the peripheral nervous system. The peripheral nervous system contains most of what we consider our nerves. It has the sensory pathways, which we will be talking about more in depth individually. So we'll be talking about each of the different sensory pathways. But it also has the motor pathways, which are subdivided into our somatic, which is our voluntary actions. So it would be things like muscle movements. And then we have our autonomic, which is our involuntary, and that is further divided into the sympathetic and parasympathetic divisions. The autonomic system is what controls the internal functions of the body that we don't have to donate conscious thought to. So our heart beating, that is an autonomic function. Our lungs breathing, autonomic. When we look at the peripheral nervous system, one of the unique features is the ganglion. The ganglion is a place where axons and dendrites meet. And oftentimes this can be lots of axons and dendrites all meeting in one place. And that has some interesting differences in the way we see ganglion appear in two aspects of the peripheral nervous system. And this chart is going to kind of show you what I mean. So one of the big things I want you to understand is the relationship between the pre and post ganglion. So in the parasympathetic, the axon is longer before we reach to the ganglion. So the pre-ganglionic axon is longer. In the sympathetic nervous system, the post-ganglionic neuron has the longer axon. So the ganglion, what that means essentially is that the ganglion are closer to the spine in the sympathetic nervous system. In the parasympathetic nervous system, the ganglion are further away from the spine, closer to the target organ. And so generally how people think of the sympathetic nervous system is that this is the side that is going to be in charge of our fight, flight, or freeze responses. So things like it's going to dilate our pupils. It's going to inhibit salivation. It's going to relax our bronchi so that we can take bigger breaths. It's going to speed up the heartbeat. It's going to prevent digestive activity. All of these are examples of the things that might happen if you needed to, run away or fight off a predator or freeze and assess your surroundings because of the fear that you are feeling. Whereas on the parasympathetic side, this is our rest and relaxation side. This is where things are good and we are able to, kind of sit back and not worry. So things like constricting your pupils. This is going to work when you are trying to digest your food. So it's going to stimulate salivation. It's not going to necessarily stop the heartbeat, but it is going to allow the heartbeat to slow down. It's going to kind of pull in your bronchi so you don't take quite so deep breaths, those kinds of things. So like I said, we are going to talk about the sensory pathways in more detail and focus on each individual sense in our upcoming lectures. But I wanted to give you some overview aspects of the sensory pathways. Starting with the benefits. Why do we even want to have senses? Senses allow us to perceive the outside world. It allows us to maintain our own bodily safety. So we have some kind of alerts to possible dangers. And this allows us to manipulate our surroundings. We are able to change the environment around us based on the information we get from our senses. So what kind of receptors do you find in the sensory pathways? It comes down to what kind of information they are responding to. So mechanoreceptors respond to touch or pressure or vibration or to the physical stretching of that anatomical structure. And so mechano meaning to shift or change. And so we're actually having that shift or movement applied to the receptor itself. Thermoreceptors are sensitive to changes in temperature. Photoreceptors respond to light energy. Chemoreceptors are going to basically respond to a chemical reaction or to a chemical itself. So you are probably pretty cognizant of the fact that smell and taste are probably chemoreceptors, but you also have chemoreceptors all throughout your cardiovascular system so that you can actually monitor your blood chemistry. And then we have nociceptors. These are pain receptors. So these are going to respond to extreme heat or cold or excessive pressure or breaking of the skin will activate these. And they're going to relay that information to the brain. These are actually incredibly important because without that sense of pain, we can actually do incredible damage to ourselves. So those receptors make up the 8 different senses that we have. So you are probably familiar with the top 5, the idea of sight, sound, taste, touch, smell. All of those are pretty common senses that we talk about a lot. And then we also have our sense of movement, so our ability to gauge where we are in space as we move. We have balance, making sure that we're not falling down all the time. And we have interoception, and that is our sense of self. That is where we're monitoring the internal situation or levels. So basically, our sense of homeostasis, our ability to maintain homeostasis is interoception. And that is going to round out our peripheral nervous system notes. We are going to start talking about each of the individual senses in our next set of videos.